right, hello Claire and Libby. This is 7-2. We're going to go through 3 new graphs. They're not really new though. 3 new graphs of cosecant, secant, cotangent. All right. In 7-1, we talked about the 3 main ones, which were sine, cosine, and tangent. All right, so above cosecant, I want you to put sine, the graph of sine. Okay? Above secant is cosine. Write this down. I'm writing, you're writing. Cotangent goes with tangent. These are the ones that they go with, all right? These are the ones that they go with. Sine, cosine, and tangent, all right? We're going to do the, I know. I think CNS, like the cosecant should go with cosine and secant should go with sine. Like that's the way that it should be, but it doesn't make sense. We'll see. Possibly. We'll see. Okay? So, cosecant, secant, cotangent. Those are the graphs that we're going to learn today. All right, here's the deal. Ready? Okay? The graph of cosecant is the one that we're going to do first. Cosecant goes with sine. All right, so here's the deal. This is what the graph of cosecant looks like. All right? But I'm going to start with the graph of sine. All right? If we look at the, well, let's just do this. I'm gonna put them over here. Okay? We'll put this on your unit circle here in just a second, okay? So if we were to graph sine, everybody watch this. If we were to graph sine, I put my markings on here. We practiced this yesterday. Here's 0, here's 2 pi, here's pi in the middle, and then I have pi over 2, 3 pi over 2, right? Sine starts, here's 1, here's negative 1, okay? Sine starts here, goes up, back down, to the middle, back down, right? This is what the graph of sine looks like. Y equals sine x, okay? Got it? This is what sine looks like. Are you guys all watching, paying attention? That's the sine function, sine of x, okay? Here is all you do. Here's all you do to graph cosecant. Ready?
Watch this, guys.
Here's all you do to graph cosecant, okay? The middle line of where sine crosses. How many places does sine cross the middle line? Or touch the middle line in that period? 3. 1, 2, 3. Do you see those little dots, right?
You say cross, not touch.
Cross or touch the middle line in that period is those 3 places. Okay? Now, where he's touching the middle line, you're going to put vertical asymptotes. Okay? Now, the reason why I say middle line and not x-axis is because when we move him up and down, he won't always be the x-axis, right? So that middle line, that's where your vertical asymptotes are going to go through. Got it? Okay? Here's how you graph cosecant. Blink and you miss it. Are you watching? Cosecant. You touch him to the tippity tip, and he makes like a little parabola. Okay? You touch him to the little valley here, and he makes a little parabola off of him. Okay? And the vertical asymptotes are your little boundaries of like where your parabolas go. Got it? Yep. That's what cosecant looks like. So, when you are graphing cosecant, you're going to first graph sine, and then just do your little parabolas off of him. Okay? Make sense? Yep. That's what the graph of cosecant looks like. Okay, the graph of cosecant, all right? So we're going to do example 1. What happens when they put numbers in there, like -3 cosecant, okay? So I always say graph the other one first. Let's graph -3 sine of t, right? Okay? What do we do when it's t and not x?
Same thing.
Same thing. It's just what the variable's name. X, Y, Z, whatever. It doesn't matter, okay? -3 sine. All right, so let's talk about what the 3 is doing. What's the 3 doing to the sine thing?
Oh, that's where it starts. Or wait, no.
What's the 3 do?
It's tall.
It's the amplitude. That makes him taller. He's a vertical stretch by 3, right? And the negative is making him go over the x-axis, so he's flipping him down, all right? So I'm going to graph sine. Let's start with our ruler. Here's 0. I'm going to put 2 pi. I'm going to make him really wide because we have the room. And then I'm going to put pi here in the middle. This guy's pi over 2. This guy's 3 pi over 2. And I'm just going to graph this one. We don't necessarily need to go to the left at all, okay? Amplitude is 3. 1, 2, 3. I'm going to put 3 there. And 1, 2, 3, -3 is there. We're going to graph sine first, okay? We're going to graph sine first, okay? So my ruler is marked. Got it? He starts at 0. He's going to go up to 3. He's going to go down to the middle, down to -3, back up to the middle. Okay, this is what the graph of sine looks like. Okay, but we don't want sine, we want cosecant, so we got to put our vertical asymptotes in there.
Isn't it negative?
It's the opposite.
Oh, poop.
You go down.
Oh, poop. I did that yesterday
That's
too.
a vulgar term.
I did. He goes down first. I forgot to apply the negative, so instead he should go down here. Boop. Right here.
You
He
pranked
should go down first, and then he should go up. Here we go.
Pranked, boy.
That's better.
Boy.
Thank you. And he looks like that. There we go. That's what
Bamboozled.
-3 sine of t looks like. Okay? All right, vertical asymptotes. In just that period, how many vertical asymptotes are you going to have?
2, 3, 3.
Three. One here. It's where he touches that middle line, right? Okay, 1, 2, 3, right here. And then cosecant just looks like this guy and looks like this guy. Okay, that's what cosecant looks like. Done. Got it?
The first 3 seconds of Mrs. Bolton coming in.
Okay, so it is very important that you know how to graph sine, because otherwise you can't graph cosecant, right? All right, good?
No way.
That's example 1. Let's go to the graph of secant. Secant goes with cosine. So when we graph secant, we're going to graph cosine. So I'm going to put him over here. So you can see him. All right, start by marking your ruler. Here's 0, here's 2 pi. This is cosine, or we're graphing cosine first, but then we're going to graph secant. So here's pi, pi over 2, 3 pi over 2. Okay? We go up to 1, down to -1. Cosine, though, starts at 1. Then he comes down, then he goes down to the middle. He makes like a V, kind of, right? But he's a curvy V. So he does one of like these. That dot is way too high. Okay, there you go. That's what cosine looks like. All right, now, how many vertical asymptotes will he have?
2.
He crosses the middle line here and here. Exactly, right? So you're going to have your vertical asymptotes there and there. All right? Same thing with secant. He's just this little parabola in the middle. Now these guys, since there's only like a half of a curve here, you're only going to do like a little half parabola off of him, right? Here's a half a curve here, so a half of a parabola off of him. So, you know, it would be exactly the same thing as sine, but he just has like little half curves, right? Questions about that? So, if you don't know how to graph sine and cosine, that's why we spent whiteboards yesterday. If you don't know how to graph sine and cosine, you are SOL, because secant and cosecant, you can't graph secant and cosecant unless you know how to do sine and cosine, right? Okay? All right, so let's do this one. Example 2. They have 2 numbers in here. Before we graph secant, we're going to graph cosine. So I'm going to change this, and this is the guy that we're going to graph first. Okay? All right, let's talk about what the -3 does. What does he do? Down 3. All right? Let's talk about the 2 does. That's the amplitude. Okay, so here we go. If I am down 3 and my amplitude is 2, what's the highest he's going to go? Shh. If I'm down 3 and my amplitude is 2, he's going to go up to -1. And he's going to go down to?
-6.
Negative
5.
5, right? Okay, so my whole graph is going to be like underneath of here, right? So keep that in mind, right? Use like small units, all right? So 1, 2, 3. This is my middle line right here, -3. I'm going to put a little dotted line right there. So that's where my middle line is. Okay? Then if our amplitude is 2, we're going to go up to -1. So here, that's my second line. And we're going to go down to -5, right? There's my other line here. Okay? Then I just have to graph my function in between there. We're graphing cosine. Are we graphing cosine? So 0, I'm going to put 2 pi over here. I'm going to put pi here in the middle. This guy is still going to be pi over 2. And this is going to be 3 pi over 2. Got it? Still those same markings. Oh, heavens. Is it negative? No? Okay, not negative. All right, cosine. Cosine starts up at 1, right? But he starts like up at the top, at the highest point, right? So he's going to start right here. At the middle, he's going to cross at pi over 2. Then he goes down to pi, up to 3 pi over 2, and there, right? So it's just like he would be, but he's shifted down. This is what my cosine will look like.
It's like a big old
Question like that?
big old bean.
Okay? Questions about that? Is that confusing? My curve is like really wonky, sorry. Okay? All right, how many vertical asymptotes is he going to have?
None.
1 or 2.
He's going to have 2. It's where he crosses the middle line, right?
Ooh,
So, where he crosses the middle line is here. Okay, Luke, you're distracting everybody else. Okay? And there, right? Do you see where he crosses the middle line, right? The middle line is where that middle portion is. Those are my vertical asymptotes. Now let's graph cosecant, not cosecant, secant. Okay? Here's this guy and this guy. And here's my little half.
He called me gay.
and my little half. So the orange one is the one that we are wanting, or whatever color that is, yellow, orange, whatever. That's the one that we want. That is secant. That is 2 secant of t minus 3. Got it? Are those two terribly hard? Okay. All right. Got them? Good?
Good for today.
Okay. A lot of your homework assignment is going to be matching and stuff, but we're going to go through cotangent first. We got to do some cotangent. And then tomorrow I might give you a day to like work on homework and stuff.
Okay.
We'll see, because we'll go over questions, I'm sure. Okay? So, graph of cotangent. All right, here's the deal. Secant and cosecant. When you're graphing those, you're going to graph sine and cosine first. When you're graphing cotangent, you are not going to graph tangent on the same one. Okay? I'm going to graph tangent over here on a different one, just so that we can compare, but I am going to graph cotangent separately from tangent so we can compare. Ready? Tangent. Tangent we know how to graph. He starts at negative pi over 2 and goes to a positive pi over 2. And every pi over 2 or over 2 has a vertical asymptote. So he goes like right here, and he goes like right here, and up at 1 and down at negative 1, that's where he's in the halfway spot. So he does this thing, and he does this thing. That's what tangent looks like. Got it? That's exactly what tangent looks like. Okay, remember him?
Yep.
Cotangent, slightly different. Okay. By the way, what is the period of tangent? Like, how wide is tangent? Tangent is 1 pi. How wide is like sine and cosine?
Half a pi.
Nope.
No, 1 pi.
Oh, it is.
The period for sine and cosine? They're both 2 pi, right? We label from 0 to 2 pi, and that's what the circle is, right? But tangent, his period is 1 pi, right? Because from pi over 2 to negative pi over 2, that's 1 pi. Okay? Cotangent, same way. He has a period of 1 pi. Here's the difference between tangent and cotangent. Ready? I think cotangent is actually easier. Ready for this? Cotangent goes from 0 to legit pi. Like he's not overlapped 0. He doesn't go from negative pi over 2 to positive pi over 2. He literally goes from 0 to pi. Okay? And he crosses in the middle at pi over 2. Okay? My vertical asymptotes are here at 0 and here at pi. Okay? But the only other difference is that he goes the other direction. He is like negative. So, differences between tangent and cotangent. Cotangent, I think, is easier because going from 0 to pi rather than negative pi over 2 to positive pi over 2, he's like shifted over and he's going down. Does that make sense? So he's like negative tangent but shifted over. Make sense? That's what cotangent is. Negative tangent but shifted over. And now keep in mind that these all like go, you know, like he has more intervals, okay? So let's talk about domain and range of cotangent here real quick. Domain, range. Okay, which one's going to be all reals? Domain or range?
Range.
Range, up and down. He'll go up and down forever. Okay, domain. What shall we put for domain? Where are the vertical asymptotes at? Where is x not equal to?
0 and intervals of pi.
0 plus and minus intervals of pi, right? Every time, pi n, every time we hit a pi, so like he'll be at 0, and at pi, and at 2 pi we'll have another vertical asymptote, and at 3 pi we'll have another vertical asymptote, and at 4 pi we'll have another vertical asymptote. Versus tangent, he's going to have vertical asymptotes at every over 2, right? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, whatever, right? That's his domain range. Make sense? Okay, now you could get away with, rather than putting 0 plus and minus pi n, you could just put plus minus pi n. Does that make sense? Okay, you wouldn't have to put the 0 on there. Or, you know, we could also do, instead of 0 plus pi n, could we do pi plus or minus pi n? Could we start talking about this one first? Right? Because plus minus pi n, that would still hit 0. So it doesn't matter. You can do either one of those for the domain. That's fine. Okay, good? All right, let's graph him. We are not going to do this part, minus pi over 4. We're not going to do that part. We're just going to go negative 3 cotangent of t. So switch him. We'll do example 3, negative 3 cotangent t, and then we'll be done. Okay, negative 3 cotangent t. All right. Okay. All right. So negative 3 cotangent t. I'm going to start him at 0. And I'm going to go over to pi, And those are where my vertical asymptotes are going to be. This is pi over 2. 2. Here's my vertical asymptote. Here's my vertical asymptote. Okay? All right, what does the negative do to him? It flips him over the x, right? Okay? Now, cotangent already goes downhill from left to right. So negative cotangent will make him go uphill, right? Like that. It'll look like that. Now, what does the 3 do to it? 1, 2, 3. Here's 3. It's like you're changing your amplitude. But how do I do amplitude on cotangent?
That's
Like
where
I
the
go up to
negative
3, down to negative 3. That's where the what is? The middle. So like partway between negative pi over 2 and pi, this part is going to be up at 3 rather than being here at 1. So instead of going like this, he'll go like this instead. You see that? Does that make sense? Okay? Instead of being the halfway point at 1, he would be like more wide. Here he's going to be like almost straight up and down. You see the difference between the two? And here he'll be at the halfway point. He'll be at negative 3. So he'll be like here instead. What's the halfway point, by the way, between 0 and pi over 2? This is pi over 4. Do you know what this one's at? 3 pi over 4, right? Like 3/4 of a pi, half of a pi, 1/4 of a pi. That's what he'll look like, okay? So, not this one. I'm going to get rid of him. Okay? But he will be this one right here. Got it? So, almost straight up and down. Like, that's what that 3 in front of the cotangent does. It changes his amplitude. Okay, got it? All right. Good, good. Okay. Use your time to do some of these on the homework. I will give you time tomorrow to work, but I'm hoping to just answer questions tomorrow. So try to get done with this as much as you can, so that way tomorrow we can just go through questions, because there's a lot of graphing ones. So, do the matching. You should be able to. Okay. Kyle just said that. Oh, wait a second. Let's talk 11, 12, 13, 14. 11, 12, 13, 14, it's matching, but they only give you 2 graphs, right? That means 2 of those graphs are listed twice, okay? When the negative is out in front here, when the negative's out front there, that's over the x-axis. What happens when the negative is right here?
Over y.
This is over the y-axis, okay? Now, let's talk about going over the y-axis. For, let's say cosine, right? For cosine normally looks like this, and he would go back this direction, okay? This is what cosine looks like. He starts up at 1, he goes down. If I reflect him over the y-axis, meaning I flip this over here and this over here, what's going to happen to him?
Same thing.
He's going to be exactly the same thing. That's why you're going to use graphs a couple of times, right? You're going to have 2 of the same graph, because it's really not going to change him at all. Does that make sense? Okay? Now, apply that knowledge to secant and cosecant and that type of thing. Okay? So, see if you can come up with what he looks like if you reflect him over x, over y, that type of thing. Okay? All right? So, do the matching. Try to do some of the graphing ones. And there you go. Okay? All right. I'm going to stop the recording.
Bye.
Goodbye, Claire and Libby.